Okay guys, so this, I don't know how many of you guys are going to care about this, but this is just a little video because today I was doing like a mini personal experiment with rigging to see if I could basically make a rig for a ball that can roll around just like by moving it. And I had a pretty good initial idea, and then I did that and I got it working really close, but not quite all the way, and then I was trying to do all this stuff to fix it, and I wasn't able to fix it, and then I kind of learned something. Anyways, so this is the thing, and here's the control, and you can roll it, right, and it looks like it's rolling, and you roll it this way, and it looks like it's rolling correctly that way as well. And you can actually roll it this way and then roll it that way, and it rolls just fine, right? No matter where you're at here. But the issue is that if I roll it this way first, and then I just try and roll this one, then depending on where it's at, it gets all weird, right? So if it's here, it'll spin sideways. If it's here, it'll spin the other sideways. If it's here, it'll go backwards. If it's here, it'll go normal forwards, right? So anyways, it's a weird combination of like it works this way, and it works this way and this way. And I can do it this way first and then get it to work just fine. But if I do it this way, then it only kind of works sometimes. And like it works there. It doesn't work anywhere around here. So anyways, I immediately when I started doing this, so the little setup that I've got is I've actually got these lattices applied to the ball. And I've got one lattice that handles rotation in one axis and one lattice that handles rotation in the other axis. And once this happened, it only took me a little bit of time to realize that the issue was coming from the input order. Right, so the X and the Z lattice are the only ones actually doing anything here, but I added the Y lattice as well, and I was actually trying to fix things through the Y lattice. But anyways, so I know that it's because of this input order, because the issue is that they work just fine when they're doing their own thing, but when one of them goes, it works just fine with the other one going after. But if the other one goes, then depending on where the first one is, then the relative motion is different because of the positioning of the other thing, which is why it only works when you've done like 360, and it still works there. But when you've done like 180, for instance, it does it in reverse, right? And you can actually take these and reverse the order of them. And so if I remember before, going this way first worked just fine, and then going the other, but now that way it doesn't work, and going this way does work, right? So that was clearly the issue, was the input order. So I was doing all this stuff to basically try and get around that, and all of this was kind of going on in the node editor, this whole setup here. And I was using this third lattice to try and basically counteract the motion of the like supreme lattice. And I was trying a few different things involving like taking the sine of the rotation in this axis and also the sine of the rotation in this axis, and then also the cosine of the rotation in the supreme axis, and like multiplying it all together, and then also multiplying it by like a negative, like an inverted version of the supreme axis's rotation. I was doing all this stuff, and like I couldn't get it to work quite right, and it was like really frustrating. And I was like, I feel like I'm so close, but I'm not quite there, and I really thought I was gonna get it. But this whole time I was thinking, going into this, I was going kind of based off of the assumption that, because this kind of makes sense intuitively to me, but I realized at the end of this whole experiment that I, in the past, had learned differently. So I should have known better, but I just like forgot. but going into this intuitively, I was thinking that any given point on a sphere, and I'm talking like mathematically right now, any given point on a sphere that is sitting on a flat plane, when you roll around that sphere to a different place on the plane, I was thinking that mathematically there was guaranteed to be one single point on that sphere corresponding to whatever point on the surface, meaning that like wherever if you were to like point to a spot on the surface and roll the ball over there, then there was one guaranteed orientation of the ball. And that is definitely not true. Because, and I'll show a quick example. So let's hide this. So I have this cube, right? It's colored differently on each side. And the reason is, and you guys probably already know this, but if I were to rotate this cube, and let's do this in world orientation. Okay, so if I were to take this cube and rotate it like 90 degrees this way, right? So you can imagine this would be the ball doing a quarter turn over, or rolling a quarter turn over to this side. And then I were to go a quarter turn back that way. So in this case, the ball would have gone from here to like this first spot and then over to this spot here. Then we have yellow on top, right? But if I were to roll up and then right first, or right up first and then right instead of right and then up, so in this case, like that, and then like that, you end up with a different side on top, right? And so obviously, depending on the path that the ball takes to get to that point, it will have a different orientation. And anyways, I realized that and I was like, oh my gosh, this is so stupid. I can't believe that I forgot about that when like going into this. And the reason that I was a little upset that I had forgotten about this is because way back when I took a linear algebra class and we were doing all sorts of math with matrices and stuff. And one of the really interesting things when you're doing math with matrices is when you're doing regular math with just like numbers, A times B is C, right? And B times A is also C, right? So like 2 times 3 is 6, for example, and 3 times 2 is also 6. But when you're doing math with matrices, that principle of multiplication does not hold up, right? So like if you have matrix A times matrix B equals matrix C, matrix B times matrix A might not equal matrix C. You have no guarantee that it will. It depends on what the matrices are and stuff, you know. And the reason why this is significant is because when you're doing math with matrices, you can represent like rotations of an object. So like for instance, rotating over the y-axis 90 degrees. You could represent that in a matrix, right? So you could take the orientation values, put them in a matrix of the thing, and then multiply it by that other matrix, right? And then now what you get out of that, your third matrix, is the orientation after you've rotated it that 90 degrees. But because matrices can't be swapped in their positions in the order of multiplication, right? Like A times B equals C is not necessarily true of B times A equaling C. That doesn't hold up. Anyways, so that's kind of what I relearned from this experiment, and I came up with like a rig that like kind of works sometimes, but doesn't work all the way. And if you wanted to actually have a rig that did roll properly no matter where you moved it, the rig that I'm doing is procedural. If you wanted to do a rig that did it that way and worked perfectly like that, the rig would have to be a simulation rig, not a procedural rig, right? So it would have to take into account the previous rotation and position of the thing, and then the new position, and in order to calculate what the proper rotation would be from point A to point B. So anyways, that's what I learned in my mostly failed experiment today. It was just like a mini one. I've been doing it for like an hour or two, I don't know. Anyways,